Hello, Algebra 2ers. All right, today we're going to talk about converting between exponential form and logarithmic form. So you're going to need something to write with. You're going to want your notebooks. You can write the notes into something where it's organized. What logarithms do for us is they give us a new type of notation to help us solve for x. So as we jump forward, let's take a second and look at this example. Okay, so this is a thinking question. Just like we were working on previously, let's see if we can change the base of 24 so I can get the same base and then just set my exponents equal to each other. So using your chart, your perfect roots table, is there anything in the column of, or in the row of 4 that I could change 24 to get the same base? It's not looking like I can change 24 into anything with a base of 4. So this is where our new notation of logs come in. Okay, so today we're going to talk about these logs and how those help us in instances like this example where I can't use same base to help me solve. Now moving forward, we're still going to use same base in some examples, but the examples when I can't use same base, that's when I'm going to have to use what we learned today. So that's where these logarithms come into play. So again, make sure you're taking really good notes, write this down. This is definitely something you're going to want to refer back to as you work on your assignment. Okay, so a logarithm is just a special way to ask a specific question. So the way logarithms look, so a generic form of logarithms is log. That little b is a subscript, so it's not on the same level, and then a equals x. So how we read this is log with a base of b of a is x. Okay, the is the equal sign. So the question we're asking then is what exponent is required to go from a base of b to reach a value of a? Okay, so how this looks, we're going to be converting between this form and exponential. So you can actually take the logarithmic form and change it back into an exponential form, which is something we're maybe more used to. So when we see something of an exponential form, we have a base in green raised to an exponent equals some value. Now how we change this to logarithmic form is now we have log, that base is going to jump down to be the b. Okay, the exponent actually jumps to the other side of the equation, and the value comes to the other side as well. So the value and the exponent almost change places, but the base still becomes the b value. So again, this is just really good to get good notes written down exactly as you see them on the screen, because in the next couple screens we'll do examples to help you better understand how we convert back and forth. All right, so this new notation. So again, exponential form is something we've dealt with, and you're probably a little bit more comfortable than log form. Log form is very much so brand new, okay? So a base, an exponent, and a value, it equals. So that's what exponential form. So the first thing we have then is we have 2 to the 4th equals 16. Now, we need to take that and we need to turn it into log form. So there's a special way we can do this, okay? If you think about log, so the very first letter of log is L. So what I'm going to do to try and kind of transform this into a log is I'm going to create an L. So watch very carefully what my marker does here on the screen. So if I make an L, I can go down through the 2, over to the 16, and back through the 4. So notice it's kind of like a bubble letter L. Or some of us might also be able to see a G here. The reason I'm showing you this is because this is exactly how I memorize how to put those numbers into this log equation. Okay, so log base of 2, so the next number is going to be 2 of, when we go across, then we get our 16, and that's going to equal, when we come back, to the 4. So all this means is that 2 to the 4th equals 16. So when I write it in my log form, 2 raised to the 4th equals 16. Now if I were to do it with the 10 raised to the 1st, again we want to make that L, so come down. That's going to be our log, so we write log because we're going to log form. Now we came down through the 10, so that's going to be my base. We go over to the 10, so then it's going to be of 10 equals, come back over to our 1. Okay, and I might be going a little bit fast, but again, the reason I know I can do this is because this is the trick we use to memorize how to change it. I'm asking what exponent, okay, what exponent is going to equal 1? What exponent on 10, or excuse me, what exponent on 10 equals 10? So here we are with the logs. All I'm doing is changing that from exponential form into log form. So one more time with this 3. So again, I'm going to start by writing log. Okay, and again, let's make our L. So log 3. So if I came down through the 3, that's going to be my base. Go over to the 1, that's going to be that value that switched sides, and then it's going to equal as I go back, it equals 0. Okay, so again, all we're doing is changing from one form to the other. So let's jump in and let's try just a couple more examples. Again, they're given to you in exponential form, and how I know they're in exponential form is because they have an exponent. We want to take this exponential form and just convert it to a log. And the reason we're doing this is because this will help us to solve log equations as we move forward. Okay, so all we're going to do here is, again, we're going to make our L, so come down, across, and then back to the exponent. You don't have to use this trick. If you want to come up with a trick of your own, you can. This is what helps me personally. So then I know that I'm going to do the log. My little subscript is going to be 1/5 of y equals x. Okay, then as I move down here to this 9 raised to the y equals x, again, let's make that L or that G, whatever you want to call it. So then again, I start by writing log. I came down through 9 first, then I went through the x, and it equals the y. And again, this doesn't look as clear as our previous slide because we're not using all numbers, and that's kind of what it's going to look like as we move forward and use these to help us solve. Okay, so then the next one, come down, across, and through. So the first thing we went through was the k of b equals 1/3. Okay, so then if we go to the other side again, still using our L, and again, we did a lot of examples just so you have really good examples in your notes. So again, we start by writing log. Your little base is going to be b of 123 equals a. Same thing here, make your L, log with a base of u of v equals -14. Okay, last one then, make your L or your G, however you want to look at it, log with a base of t of 2/3 equals x. So I went through these examples a little bit quickly, but once you get the hang of it, it's pretty simple. Okay, if this is confusing, make sure you're jotting those notes or those questions down so we can answer those when I see you. So now what's different about these ones is these ones are given to us in log form. They have the log already written, and the reason I know it's log form is because it says log. Okay, so when it's in exponential form, that means it has an exponent. When it's in log form, it tells us log. It says log right there. So now I want to go from log form to exponential. So I want to change it back into an exponential function. So what's nice about this then is there's another trick. Okay, so if we think about it, remember that this letter here was still our b or our base. The value and the exponent switched places. So the way that we can remember how to change this into exponential form is we can actually make an e. Okay, so we start with the u, we go all the way over to the v and come back through the 15/16. So again, I'm going to exponential form, so I'm going to make an e. Okay, so then I'm going to take again the u raised up to the v equals 15/16. And again, I was able to remember that by using the e. Or if you think back to this third slide that we covered, we talked about how you change back and forth from exponential to logarithmic. Okay, so let's try that again. Again, if I'm going from logarithmic to exponential, I'm going to use the e. So I'm going to start here with my base, and go around and come back through the x. So again, I'd get 7/4. The next thing we went through was the y raised to the y equals, and we came all the way through the x. Okay, so in our third example, same thing, we're going from logarithmic to exponential. So again, we're going to make the e, and we always start with the base. Okay, in both our L and our e, we start with the base. So we go m over to 9/11 back through the n. So m raised to the 9/11 equals n. And again, if you don't want to use the e's or the l's, you can go over and kind of come up with some other way to memorize going from each step. Okay, this is just what's helped me, and I'm hoping it'll help a lot of you as you move through this, because this is kind of unknown territory. It's something you guys probably have never seen before. So again, over here to example 4, start with the base, make your e. Looks like I'm going to have v raised to the 4th equals u. Okay, fifth example then, again, start with our base here. So 2 raised to the b equals k. And lastly, again, start with our base, come all the way around, make the e. Y raised to the -8 equals x. And again, I know I went a little bit fast, but make sure you jot down those questions and I can get those answered next time I see you. So thanks for taking good notes. I will see you later.